All right, we continue. Translating business relevance to QoS treatments. Apply RFC 4594 based marking, queuing, dropping treatments. So these are basically the classes that we can apply to the types of traffic that we're talking about. Just to clarify, right now the table might seem overwhelming because it's the first time we're actually looking at it, but that's why I recommend you to read the Cisco official CCNP guide. Maybe first CCNA, the CCNA official Cisco guide as well, because there they explain very well how the data is classified. We have multiple possible markings, and this is talking about DSCP, which can go up to 64 bits of classification, and that can probably be too much, too many bits to classify data. So the Telecommunications Union created RFC 4594, and well, basically that's what we're looking at. Those are classes, up to 12 classes by default. That's what Cisco recommends. Cisco recommends 11. The Telecommunications Union created 12 classes, and they are called per hop behaviors. So as we can see here in the table at the top, it says per hop behavior. Application classes will have a specific per hop behavior by default. That's the recommendation. So they can be changed depending on your business needs, but normally the business relevance is explained in this table right here. So for example, let's just read a little bit to get an idea. Voice over IP telephony. It gets the per hop behavior EF, expressed forwarding. That's what it means. And to be a little bit more technical, something you'll probably understand in the future if you read the guides, will have a value of 46. All right, 46 is the maximum priority. Priority queue, Cisco IP phones. All right. Broadcast video, Cisco IP video surveillance, Cisco Enterprise, and then real-time interactive video, Cisco telepresence, multimedia conferencing, Cisco Jabber, Cisco WebEx. So as you can tell, multimedia streaming, the highest priority goes normally to real-time type of applications. Cisco WebEx, what is it for? Conferencing. Whenever you get an interview, for example, at a company, you'll get hired. That's a type of priority thing, right? That's a type of priority traffic. Cisco IP phones, Cisco telepresence. All of those things are real-time traffic. We want to make sure we're looking at them. It says there IP video surveillance. All right. There's a security team watching all the time, maybe checking the security physically in a building. They want to make sure that they're getting accurate information, right? Real-time information. They're looking at the people going there. They're looking at the server rooms, all the important things that are inside of a building. They're able to do the proper surveillance, right? So that's it. That's the most important type of traffic. As you can see, there are different codes. CS5, CS4. They're talking about class of service. That's a layer 2 type of marking. all right, from the QoS. They also call it QoS, class of service, where we have 7 bits. Here we're talking class of service 5 and 4 are getting that type of priority. And then we have AF4 and AF3. That's assured forwarding. That's a type of DSCP marking. All right, that happens at layer 3, where we have those 6 bits available for marking. So that's getting AF4, priority 4, and AF3, priority 3. And then we have network control, signaling, and administration and management type of traffic. So EIGRP, OSPF, BGP, HSRP, H.323, SNMP, Simple Network Management Protocol, SSH, and syslog, all of them in green color in the middle. They are relevant type of traffic, but they can have a little bit lower type of precedence of priority. All right. They are very important because those are used for management. We also want to make sure those packets reach their destination. But normally they're a little bit less critical because we have some type of signaling mechanism, yes, that will allow them to be sent over and over again. If there's a delay, if there's a packet loss, OSPF, for example, and EIGRP will normally recover. BGP will normally recover that packet, resend it. SSH for for device administration. Simple Network Management Protocol for monitoring. Syslog also for gathering logs from the devices. Then we have transactional data, which is also part of the network control. Bulk data, any type of, that's lower now. Right there, we're already talking TCP type of data. If some packets are dropped from email, for example, the email can be resent later on. All right, it goes to the pending outbox instead of the sent items folder. If you send an email with Gmail, for example, it will go to the outbox type of folder. It will wait some seconds and then try to resend it again. All right. No big deal with those packets being lost, being held for several minutes or several seconds. Those type of data, that type of information can actually hold longer than the more critical data. All right, that's why we mark it here. Here it has a yellow color, orange color. Really, in the devices, instead of having colors, they have numbers, but the numbers represent the priority. That's the difference. Here in the table, we have them as colors, but whenever we're actually applying the priorities, the red color would signify a very high number, and the yellow and white and gray colors, very low numbers. All right, for example, red could represent 46. A purple could represent between 27 to 36, for example. Green, a little bit lower. The yellow and white, probably 5s, maybe 9s. All right, and then scavenger traffic, that has the lowest type of priority. YouTube, Netflix, iTunes, any type of just residual, we can say, type of traffic, scavenger traffic, BitTorrent, as we said before, and Xbox Live. All those things, normally they're left with just CS1, class of service 1. All right, very, very useful to know. And And that's it. That's the traffic is marked. We're talking about differentiated services. Differentiated services. Because integrated services is RSVP, which actually reserves bandwidth regardless if it's being used or not. The bandwidth is reserved, so it's very inefficient. That's what Cisco says. Cisco recommends to use differentiated services where the traffic is actually marked, and if there's bandwidth available, then that type of traffic can use the specific bandwidth amount that you defined, or even more. It depends on the availability. It depends on the congestion. And, well, application classification rules. How? This is just telling you practically. How can you define what criteria will you take into consideration to classify your traffic? And here is it control plane? Then you can mark it accordingly. You can put one of the priorities to it. That's it. Is it a signaling type of protocol? Then apply the corresponding priority. Is it management? Is it voice? Then mark it as voice. Alright, that's it. Now it's going a little bit more advanced here in this table right here, because it's talking about elasticity, which is a subject that corresponds to the collaboration engineers. And it's starting to go deeper into the technical side of it. Alright, but the overview, we just saw the overview. And here, it gives us a little bit more useful big picture type of concepts. Let's read a little bit. The quality of service challenge. Today there's a virtual explosion of rich media applications on the IP network. This explosion of content and media types, right, both managed and unmanaged, requires network architects to take a new look at their quality of service designs. Yeah, basically it's saying in recent times, voice over IP and video conferencing are very, very important. Now we have a lot of home office type of jobs, right? Telepresence type of communication. Many companies are already using voice over IP and video conferencing to talk with their employees from their homes, from their home office. It's becoming every time more and more important for businesses. So quality of service has to be considered every time more and more, which those are actually good news, because it seems like there will be more job, obviously, for network engineers who can apply quality of service. In terms of the CCNA test, it's part of the IP services mainly. IP services type of subject, which only represents 10% of the test. But in the practice, it's really, really important. All right, articulate business intent and application relevance. The first step may seem obvious and superfluous, but in actuality, it is crucial. Clearly define the business objectives that your quality of service policies are to enable. These may include any or the following. Any or all of the following, Guaranteeing voice quality meets enterprise standards. It's just the same thing as before, it's just repeating. Ensuring a high quality of service QoE for video increasing user productivity by increasing network response times for interactive applications, managing applications or bandwidth hogs, identifying and deprioritizing consumer applications, improving network availability, hardening network structures. Actually, the same thing as before. And here we have the recommendations. RFC 4594, which is the same table we saw before. And here, the algorithm to just choose the type of traffic, how to classify it. Now, how do we actually classify it? Here, we already finished the introduction, and then it goes very deep into the wide area network design, which is something that collaboration engineers will actually learn. And what we're talking about is actually just basic quality of service concepts, and maybe going a little bit deeper with the Cisco CCNP professional certification, talk about the configuration of it. All right, NBAR, QoS, marking, classifying, policing, shaping, all of that can be configured. How is that configured? We will actually check it from the official Cisco guide. All right, let's go ahead and do it. Please subscribe and share. Thank you.